Okay, so ball 1 is dropped from rest at t equals 0 from a tower of height h as shown. At the same instant, ball 2 is launched upward from the ground with initial speed v naught. If air resistance is negligible, at what time will the two balls pass each other? And we have 5 answer choices. So this is a kinematics problem. Maybe you could do it with energy. I don't know, but it's definitely possible with kinematics. So let's get into it. We want to find, hey, when are their y values going to be the same when their t values are going to be the same, right? At what t value will they be at the same height, right? Because if we think about our, like, a coordinate system, right, if we kind of say, like, okay, I don't know how I'm going to do this. Maybe I'll do it like this. I'll do it actually like this. Hey. So, if this is x and this is the y direction, we're primarily focused on that y direction, and this is our origin. This is when y is equal to 0, right? And then this is like, you know, at y equals h, right? When the height of the building. So there's going to be a certain point, I'll say even x, y, like that, right? A coordinate where they're both going to be passing each other. They're not going to be the same x, but they're going to be at the same y. So let's write an equation as let's write an equation for the y value as a function of time, so that we can kind of equate them, and then we can solve for when t is going to be, like, at what t value will they have the same y. So it's actually a bit more straightforward for for ball 2, right? Because if you think about it, for ball 2, we can use the kinematics equation. Change in y equals 1/2 at squared plus v naught times time. The reason this equation jumped out to me first is because, hey, I want to do stuff with the y, right? It's displacement. I know the acceleration is always negative g, negative 9.8 meters per second when something's in free fall. And I know I want to figure out stuff with time, and I also have the initial velocity. So what is going to be, it's like, you know, y as a function of time. Well, I know that its displacement at a certain time is going to equal y minus 0, right? If I'm doing the final y minus initial y is 0, right? It starts at the origin, so I can actually just erase that. Equals 1/2 at squared plus v naught times time. And I'm just gonna, in the back of my head, I'm just thinking, remember a is negative g. I'm just leaving it like this just because I don't know where we're going yet. I don't know if we even need that. You can substitute a negative g. It's up to you. Actually, let me just do that. And the reason I want to do that is because I want, where's my eraser? Well, I don't have an eraser, I guess. I want to make directions consistent, right? Negative 1/2 g. The displacement is upward, so this is positive. Velocity is upward, this is positive. Negative 1/2 g, right? The acceleration is downward, it's got to have a negative, just so we are consistent with direction. That's one thing I urge you to do. Okay, so now we have ball 1. So you might be tempted to do the same thing. Okay, y is equal to negative 1/2 gt squared, no initial velocity. You might be tempted to do that. But remember, think about what this is saying, right? It's saying that when time is equal to 0, right? At the very instant it's let go, the y is equal to the height. But the y is equal to 0, right? When you plug in 0 here, you get 0 here. But we know that at the instant it starts, it's going to be y is equal to h, right? It starts at the height of the tower. So instead of having just y, remember we're doing change in y. Right? And I'll just write it here, change in y. Change in y is always equal to your y final minus y initial. What's the y final? Well, it's going to be, you know, the y at a specific time, whatever that y value is. And then minus the y initial, that's height, that's h, right? Is going to equal negative 1/2 gt squared. Or in other words, y is going to equal negative 1/2 gt squared plus h. Okay, so now we got a function of a function of y is a function of time for both of these things. I know that they're going to be equal when they pass each other, right? They're going to be at the same y value. So what I can do is, yeah, just set them equal and solve for t. So I get negative 1 half gt squared is equal to negative 1 half gt squared plus, oh, and I forgot the plus h here, no worries, plus v naught times time. Okay, so now, hey, same term here. You can cancel it out. So that's another reason why you didn't really need to put negative 1 half, or you didn't need to put negative g into this equation, because either way the term was going to cancel out, but that's okay, we did. So h is equal to v naught times time, and then, I wrote that wrong, then you just divide h over v naught, and you get equal to time. So that would be answer choice C. So yeah, hopefully this video made sense. Have fun with kinematics during the summer.